Hi everyone, welcome to this very interesting class on calculus where we are going to learn about integration. This is the introductory class on integration where we are going to see what is integration. It's the reverse of differentiation. We're going to look at the important formulas and the substitution method, and then there will be more classes where we'll be going into other methods of integration. Integration is a big topic, but don't worry, I'm going to break it up and make it absolutely easy for you. So are you ready to learn integration with me? Keep your pen and paper ready and let's start. Before we begin, just a quick reminder, do check out the courses on our website manochaacademy.com and our Android app. All the links are given below and be sure to share it out with your friends as well. So guys, all of you know what is differentiation, I hope by now, right? Because we are going to go into integration, but just a quick recap, what is differentiation? In differentiation, we had a function fx, and then we say we are doing a differentiation or a derivative. And remember this whole formula where we said if the limit exists, so all that you have seen before. And so basically differentiation we were denoting with these different symbols like dy by dx, right? Or ddx of fx, or f dash x, or capital D of fx. So usually we use these ones, right? F dash x or dy by dx, where basically it is the derivative of the function, the change of the function y with respect to x. And remember, we have done all these standard formulas in differentiation. If you don't remember these formulas, please learn them because they will definitely help you a lot in integration. Okay, so these are all the derivative formulas. Differentiation formula, like differentiation of constant is 0, and differentiation of x to the power n x to the power n minus 1, and all these different formulas, right? E to the power x, log x, and so on. Then you have a bunch of derivative or differentiation formula for the trigonometric functions. So formulas you have to learn, and best way to learn them is write them down. Very, very important. These are all your trigonometric functions, inverse trigonometric function. Now we are going to take a look at integration, or what you call as integral. Now if you have a function fx, right, let's take if there's some function fx which is differentiable, okay, which is differentiable in an interval, and f dash x is the derivative. F dash x, which basically means your dy by dx, right? This guy is the derivative of fx, okay? So I give you some function, like let's say the function is suppose x square. Then what is its derivative? Differentiation of x square is 2x, right, by the formula method. Now if I give you f dash x, can you find fx? What do you guys think? So basically we are saying that we have been given the derivative f dash x, can we find now the function fx? And the answer is yes, yes. And how do we do it? The answer is using integration. So that's what we are going to discuss today, integration, or taking the integral of this f dash x, because our goal is from f dash x we want to get fx. So this is an important thing to remember, that differentiation and integration are opposites of each other, right? They are basically opposites, or the reverse process, right? So from the function we know how to find the derivative differentiation. So f dash x, right? So function, we can write this as, when I say f, it means if you take the variable fx, we know how to find the f dash x. Going from here to here is called differentiation, or finding the derivative. Now I am talking about the reverse. Going from f dash x to fx, that is called integration, or finding the integral. So basically you can say they are the reverse of each other. Clear? Now what is the meaning of this word integration? Integration means to combine, right? To combine. That's why this analogy is given in the books. It's like joining puzzle pieces. All of you love playing puzzles, right? I loved them in childhood, right? I had all these different Disney puzzles and it was amazing. You know, those 100-piece puzzles sitting and joining. So what was I actually doing? I was doing integration. Of course, if you said that, I wouldn't have played the Disney puzzle, but basically joining the puzzle pieces, that is called integration, okay? Integration. And you'll get a more visualization of this, you know, when we do actual integration with the graphs and stuff, but just keep that in mind. So this is what we are not going to be discussing today, like definite integrals, that where basically, you know, we break down the graph into tiny parts, okay? We break down the graph into tiny parts because let's say you want to find the area of this graph. Now since the values are changing as x is changing, if I want to find the area from A to B, then I need to do the integration, right? So this will give me the area of the graph, and this is what you call as definite integral because the limits are fixed from x equal to a to x equal to b. But that we'll do in a separate class, just to mention to you, right? So that is why the joining of these parts, right? Joining of the puzzle pieces is integration, which finally gives you the area under the curve. Some of you may already know this, but that is the next part. Today we are going to do indefinite integrals, right, where the limits are not given to you. Okay, so what is the meaning of this? That integration, remember we said it is an inverse process of differentiation. Integration is the inverse or the reverse process of differentiation. So for example, I said d dx of x square is 2x, correct? D dx of x square is 2x. So now that means this is the function is x square, this is its derivative 2x. Now if I say let's integrate, integrate means this is the symbol, okay? So this is the symbol of integration, guys, this, okay? This is the symbol of integration, this curly or stylish kind of, it looks like a curve or an S. So this is my, see, this is my derivative, d dx of x square is 2x. So this is like my f dash x. All of you got this? This is my fx and this is my f dash x. So if I integrate f dash x, what will I get? I should get back fx. Remember the picture we just saw? If we integrate f dash x, we should get back fx, correct? So therefore, integration of 2x will be what? X square. Similarly, if you do d dx of x square plus 2, if I do this, then I'm going to get 2x. Why? What about 2? Because 2 is a constant, so differentiation of 2 is 0, right? So integration of 2x can be what? You'll say pick up the function again, the reverse. So can I write over here x square plus 2, right? d dx of x square plus 2 is 2x. So integration of 2x, I just copy pasted the function there, right? We love copy paste. Same way, if I say d dx of x square plus 5, d dx of x square is 2x plus 0. So integration of 2x will be what? X square plus 5. Now you're like, wait a minute. Integration of 2x is x square, integration of 2x is x square plus 2, integration of 2x is x square plus 5. Then what's the answer? This is why whenever you do integration of 2x, don't leave it just as x square, right? Here I can say x square plus 0. Don't leave it like this. Its integration of 2x is x square plus some constant capital C, okay? This basically is a constant. So don't forget to add this plus C, otherwise you will get a wrong. Okay, and this is what is called your indefinite integrals, right? So you will see this plus constant. Why? Because all of these are possible, all of these are correct. Constant can take negative value, 0 value, positive value, anything. This could be x square minus 5 also, right? So please remember, this will be your answer, because when you differentiate this, the differentiation of constant is 0, you are left only with 2x. Is it clear? So very, very important, note this down. Don't forget to write plus C, the constant. And if you guys have any doubts, please put it in the chat. Clear? So integration as an inverse process of differentiation. So same way, when you do d dx of sin x, what do you get? Differentiation of sin x is cos of x. So if I integrate cos x, right? And when we are doing integration, please note, it is integration of 2x with respect to dx, right? So we write like this. In differentiation, we were doing d dx. dx comes in the denominator. Here it's up here. Integration of 2x dx. Okay, that's very important. Integration of, so when I say integration of cos x dx, what will it be? d dx of sin x is cos x, correct? So therefore, what will be your answer? d dx of cos x will be sin x. But will you end here? No, don't forget to put plus C constant. Plus C is very important. So integration of cos x dx, sin x plus C, okay? So clearly you can see that since it is an inverse process, we sometimes call the integration as antiderivative, right? It is the opposite. Derivative, we are doing the opposite step, antiderivative. Clear? Okay. So what is the comparison between indefinite and definite integral? So indefinite, remember what I said? That you need to make sure, and constant you will see typically you can write small c or capital C. We typically write it as capital C. So whatever notation is used in your book, doesn't matter, you can write K, whatever you want, but typically I am going to be using capital C here, okay? So if d dx of fx is the small fx, then integration will be fx plus C, okay? And this kind of integration where there is no interval given it is called indefinite integral, right? And you have this plus c. But if certain limits are given, which you might have seen in physics, right? Suppose they say integrate from x equal to 1 to x equal to 5 or x equal to a to x equal to b, then it is called a definite integral, okay? And this is the application. We learn it in the application because it will give you the area. What will that give you? That's going to give you the area under the graph. It's going to give you this area. So we'll actually end up with an actual number. Here what are we ending up with? A function plus a constant. Here you'll end up finally with an actual number. So when you do integration, you put all those limits, but that we learn in a separate video. That's not the goal today, but basically you find the area bounded by the graph, or we say area under the graph. Okay, this lands up with a, you get a finally a number over here. Clear? So as I was saying, they are opposite of each other, right? So if you know these differentiation or derivative formulas, then integration or antiderivative becomes very easy. Like take a look at this. d dx of x to the power n plus 1 by n plus 1 is x to the power n, right? And here integration of x to the power n, see exactly it will be the reverse. So here basically we have made up the formula for x to the power n. So if you see x to the power n plus 1 by n plus 1, can you see in derivative, you guys know, how did we get this? Because when you do d dx of this, n plus 1 times x to the power, reduce the power by 1, x to the power n by n plus 1. Can you see n plus 1 is getting cancelled? So that is why integration of x to the power n will be x to the power n plus 1 by n plus 1 plus c, okay? And obviously n should not be equal to minus 1, otherwise division by 0 problem. Clear? So this is your first most important integration formula. Is that clear? Now d dx of x is 1, d dx of x is 1 when you do differentiation. So integration of dx basically means 1 dx, right? So when we write this, basically what are we talking about? We are talking about integration on this side. So it's basically like doing integration on both sides. Can you see? So if I do integration on both sides, this differentiation integration will sort of, they're anti. They will sort of cancel each other. So see, I'm left with x plus c. Clear? So that is the meaning of this. Differentiation of sin x is cos x. So integration of cos x is sin x plus c. Similarly, differentiation of cos x is minus sin x. So integration of sin x will be minus cos x, right? Because that negative, so you'll have a negative this side. So just be careful of that positive negative, otherwise you'll make a mistake. Okay, so integration of cos x is sin x, but integration of sin x is minus cos. Okay, and same way here you can see tan x, see sec square, see sec, that was differentiation gave you sec square x, so integration sec square is dx is tan x plus, and so on. So clearly from these trigonometric formulas you can see they are opposite of differentiation. Can you see that? Okay, so nicely I've given you this list. That's why make sure you write it down and learn it, and don't forget the plus c. Then moving on, we have some more formulas. Okay, and here your job is to learn the formulas so that you can quickly apply them. So remember derivatives of inverse trigonometric functions. Can you see? There are lots of these formulas. Please check. I hope there's no sign mistake here, right? No typing mistake. So integration when you do, so let's take an example. d dx of sine inverse x is 1 by root 1 minus x squared. So integration of 1 by root 1 minus x squared dx will be sine inverse x plus c. Got the point? Just the reverse. And similarly you have the remaining formula. Got it? So here you have all these ones with the square root. These are the little simpler looking ones. 1 by 1 plus x square is tan inverse x, and so on. And then you have finally the log based and exponential, right? E to the power x. So d dx of e to the power x is e to the power x. So this one simple. Integration of e to the power x is e to the power x, same thing, plus c. So e to the power x is a nice function, right? When you differentiate it, you get the same thing. If you integrate it, you get the same. Interesting function. Then d dx of log x is 1 by x. So integration of 1 by x is log. And what is the meaning of this? Because log, you know, the value has to be positive. So you have to take the absolute value, or what do you say, modulus, right? So positive value. This means positive. Absolute value, right? And same way d dx of a to the power x by log a is a to the power x. So integration a to the power x dx is a to the power x by log a. Log here means natural logarithm. Okay, so remember that this log means log to the base e, or we can also write it as ln a. Very important. So ln, natural logarithm to the base e. This is not log to the base 10. That's why because they are the reverse, we use this term antiderivatives. Now what are some important properties of, remember we are talking about indefinite integrals, means there is no limit, so that's why the plus c comes in. So when you do integration of f dash x, so if you do integration of f dash x, the derivative, you will get back the function. Like we saw, it is with the, it's basically the reverse, right? So of the differentiation. Now if you do integration of fx plus gx, right? If you do integration of, there are two functions, right? Suppose this one is, for example, if this is x square and this is, sine x. So obviously you can break it down just like in differentiation we said, integration of fx plus integration of gx. So you can break them down, simple. This can be plus or minus, right? If you have a constant here, just like in differentiation, the constant came out, same thing in integration, constant comes out. No big deal. The constant comes out of the integration and you just have to integrate the function. And if combining all this knowledge, right, these two lines, you can see if you have k1 f1x plus k2 f2x and so on. So see, the constant is coming out of the integration and we are breaking down this complicated thing into its individual functions. That's it. So very simple properties which you keep in mind when we are doing the numericals, because it makes things simple, right? Breaking them down makes it easy. So there are different methods of integration, right? Because integration, this is where students get scared of this topic, is because there are so many techniques, right? It's like a bunch of techniques, and don't worry, we are going to go one by one, so it'll all settle in your mind, right? So what are the different techniques? One is by formula method, right? Like what we were seeing right now, antiderivative. So using this formula, this is what I call formula method, using your antiderivative. You can call it antiderivative method, formula method, right? So this is the one, just directly using the formulas. Next is by substitution. This also we'll look at. So in today's class, we are going to look at these two, okay? Then there is using trigonometric identities. So please make sure you revise those identities. Then some particular special functions, then partial fractions by parts, okay? So there are different ones. So let's first go ahead and start off with the integration by formula method, the antiderivative, which is the easiest. And sort of you should do this. You should try this out. If this doesn't work, you go for substitution. Otherwise, if there's some trigonometric identity that helps you, you go like that. So this is how it is arranged, so that it becomes easy for you to sort of, do a hit and trial of which method is working. So let's start with the simple question. You have to find the integration of x to the power 5, and sometimes in the books it's given like this, by the method of inspection, or find the antiderivative, right? So take a look and see how will you integrate x to the power 5. The question is x to the power 5, and always they'll say dx, right? This is the integration that we have. So the function is x to the power 5 dx. Now what did we learn from the integration formulas? Remember? So take a look here. We are going for direct formula, antiderivative formulas. This is the very, very important formula. Just like differentiation, you have x to the power n. Here it is x to the power n plus 1 by n plus 1 plus c. So please learn that. I'll write it for you also once here. Very, very important formula. Integration of x to the power n dx is x to the power, increase the power by 1, add 1 to the power. And by the way, n need not be an integer. Don't think, oh, n means natural number or integer. No, no, no. It can be fractional power also. It's a number. As long as n is not 1, because see in the denominator, and that same power that you wrote there is in the denominator. So x to the power n plus 1 by n plus 1, and of course don't forget our constant. Otherwise the capital C will cry. That's why I think they named him capital C. He'll cry if you forget, he or she will cry if you forget him. Okay. So now how will you do this? So tell me the answer, come on. Simple here. N value is 5. So x to the power 5 plus 1 divided by 5 plus 1 plus the constant. So simply the answer will be x to the power 6 divided by 6 plus c. Is it clear? Now here you don't have to take c as LCM and put plus 6c and all. You don't have to do that. Just the answer ends here. Okay, just the answer ends. Clear? Simple one. So there you can see that's our answer, correct. And this is very important formula. This one noted down. X to the power n plus 1 means power plus 1 divided by that same n plus 1. Okay. Next, try this out. You have to do integration of cube root of x. Cube root of x. So this one we can write as integration. Cube root means what? X to the power, all of you know this, square root is x to the power half, cube root is x to the power 1 by 3. And I told you that n you can use for fractional thing also, right? So what will this be? This will be x to the power that 1 by 3 plus 1 divided by 1 by 3 plus 1. And plus our constant capital. So now to make it nice, take the LCM, 4 by 3 over here, divided by 4 by 3, same thing, plus c. You can take the 3 on top to make it look nice, 3/4 x to the power 4 by 3 plus c. Got it? Got it? Check my answer. That's it. That's all you have to do. So you can see it's so easy. We are directly using the formula. See, we are directly using this formula, and I hope all of you got this answer. And this is the important formula we have. Got it? So, and you have to be clear about these exponent things. That cube root means x to the power 1 by 3. So it converts into our x to the power n form. Next one, find the antiderivative or integral of 3 by x square dx. See, always that dx will be there, right? It's with respect to dx. So when we are doing this integration, 3 is a constant, x square is our function, right? The actual function is 1 by x square. So we are going to pull the constant 3 out and say this is going to be equal to, or let me write it here, this is going to be 3 integration of 1 by x square dx. Now you'll say, sir, you didn't tell us a formula of 1 by x square. But come on, you can convert this to a exponent, right? You can use your knowledge here. 3 integration of, what will this be? X to the power minus 2 dx, minus 2 dx, that's it. So when you integrate this, what will you get? X to the power minus 2 plus 1 divided by minus 2 plus 1, that's it. Don't forget the constant. So 3 x to the power minus 1 divided by minus 1 plus c. That should be your answer. Done? Simple. Please check. Minus 3 by x plus c. Correct answer. So that's it. Just write it in the correct power and very easy. Next question. This one can you do for me? Integration of dx. Integration of dx. You'll say what to do here? Integration of dx. Dx means what? This is just 1. I can multiply here with 1. So remember we had talked about this. This is basically integration of dx will give me x. And you can check that because when you do ddx of x, it is 1. So this is simply the answer. This is where the puzzle will make sense to you. See what we are doing. We are integrating dx. Basically, if you have taken x and you have broken it down, guys. You have taken, let's say this is x. Let's say this is Mr. X. Okay. And you have broken it down into tiny parts, into tiny bits. That's what Newton did, right? That's how calculus was invented. That break it into tiny dx's, tiny parts. And integration means what? This basically means, integration means doing a sum of all these dx's. So integration is the reverse. This is breaking it into tiny dx, right? Tiny parts. Integration is saying add up all these dx's. What will you get? X. That's exactly what we've got, right? That's exactly what we've got. That's just thinking over there that we are breaking it. Actually, we are finding the area under the line 1, right? But just to give you an idea that you are sort of joining back the puzzle pieces. So see, that's why we are getting the answer here 1. Okay, and yes, the proper way is that 1 is nothing but, so the proper way of doing this, see here, how did I do? I did by the intuitive method, right? ddx of x is 1, so integration of 1 will be x. But you'll say, sir, what's the proof of that? Here you go. Okay, this is the proof that we are still using the same formula. X to the power n. Now 1 is nothing but x to the power 0. 1 is anything to the power 0 is 1. So x to the power 0. And now if you put, so basically our n is equal to 0 here. Yes or no? N is equal to 0. So now if you substitute 0 plus 1 divided by 0 plus 1, see, same answer. Oh, did I forget the plus c? Now c will definitely cry. See, my mistake. In the rush, I forgot the plus c. Very bad. Okay. So you don't forget the plus c. Very, very important. And typically we write capital C, right? For constant. So that's why I say he is the cry baby. He or she is the cry baby because we forget it. So don't forget in the exam. Remember C for cry. Otherwise it will start crying. Got it? Next question. Find the antiderivative, right? Or integrals means the same thing, or integration of, everything is same, of sine 2x dx. How will you do this? Come on, try it out. Integration of sine 2x. Tell me, what will be the answer? See, if you think in terms of antiderivatives or in terms of derivative, we know that ddx of cos x, differentiation of sine x is cos x, differentiation of cos x is minus sine x, right? So if I want to do the reverse, if I want to do integration of sine x, that will give me what? That will give me minus cos x. Simple. But the problem is they have given me sine 2x. So if you write your answer that, okay, so this is simply integration of sine x is minus cos x. So if you write, okay, that's going to be minus cos 2x plus c, I think your answer will be wrong. Check. How to check? You'll say, how do I check, sir? Do the differentiation of this and see if you are getting sine 2x. Suppose you found this as the answer. Now you do this for me. ddx of minus cos 2x, come on, do it, plus the crybaby. So ddx of minus cos 2x plus c. So when you do differentiation of this, minus, and ddx of cos 2x. ddx of cos 2x is minus will get cancelled. So this will basically give you sine 2x. And remember the chain rule in differentiation, because this you are treating as sine, right? Sine, differentiation of cos 2x, sorry, the 2x you are taking as x. So I have to differentiate 2x also once again. So I'll get 2 sine 2x plus c. Am I correct? Oh, plus c will be, differentiation will be 0. Okay. So am I correct about this? So therefore our answer is wrong, because we wanted sine 2x. You have given me 2 sine 2x. Sorry, it's wrong. So what is the answer? Everybody remembers in differentiation how to do. d dx of cos 2x is what? Minus cos 2x. This will be minus sine 2x. So minus minus will get cancelled. And then don't forget, you took this as a cos x, right? d dx of cos x was minus sine x. And now I have to differentiate 2x also. That will give me 2, right? So the 2 comes out. 2 sine 2x, yes or no? Yes or no? So therefore, our answer, this answer is wrong. So but you say, sir, I'll fix it, right? So what will be the answer? If I've got double the answer, so actually it should be divided by 2. Actually it should be divided by 2. Now if you do this, you'll see the answer will be correct. So the answer of this is actually minus cos 2x by 2. So what is the moral of the story? That if you do integration, look at this carefully guys, look at it very carefully. So first what you do is, just like differentiation, you imagine you're doing integration of sine x. If you're doing integration of sine x, what will it be? Minus cos 2x divided by, so whatever you took, you differentiate that. Differentiation of 2x is 2 and then divide by that. In differentiation, we were multiplying 2 sine 2x, right? So here you basically divide with that. So integration of sine 2x is minus cos 2x, correct? Minus cos 2x divided by, differentiate 2x, divide it over there, and don't forget the plus. Is this clear? But you'll still say, I'm confused, sir, right? What is this? So this is that magic formula, right? But I'm going to show you the proof of this by substitution, okay? So because what we are going to do, just like when we learned the chain rule, we can say let 2x equal to t. So we're going to get there and we're going to see this sum again. We'll revisit it. If I forget, remind me. We'll revisit this and see its proof using substitution. So this formula can be proved by, we'll revisit in substitution, okay? But for now, basically, what is the technique or the trick? Do its integration as if it's x, then differentiate the whatever's inside whatever you took as x, and divide by that, right? Got it? Did all of you get the trick here? Okay. So there you can see integration of sine 2x. If you directly do it, it will be cos 2x by 2, right? This is not the substitution method. This is the direct method, formula method. Now if I give you integration of e to the power 3x. Now see, we have learned that d dx of e to the power x or integration of e to the power x, that antiderivative list I showed you, of course with dx, is e to the power x plus c. But here once again that problem, there is 3x. So what will you do? You'll say, no problem, sir. I'm going to write e to the power 3x, and then what is the rule we said? Differentiate 3x. Do d dx of 3x. d dx of 3x is 3. What you got, you divide by. Divided by 3 plus, there you. And if you don't believe me, you don't believe this answer, you differentiate this and see you're going to get exactly e to the power 3x, because when you differentiate this, you will get 3 e to the power 3x. Check it, check it. If you still don't believe the answer, you do d dx. Don't believe what I say, right? If you do d dx of this guy, the answer, we are going to get 1/3 times differentiation of e to the power 3x will be e to the power 3x, and by chain rule d dx of 3x, which is 3 plus c. See, the 3 is getting cancelled. That is exactly what we want. Oh, plus c, differentiation will be 0, right? There you go. Because always the answer you get, if you differentiate, you will get the question. You will get back to the question. You can check it. So there, okay? So this is the quick rule that you can apply, that differentiate and divide. In differentiation, we were doing differentiation chain rule. So this is like a sort of the anti-chain rule, right? You can give it a name here. This is like your anti-chain rule. Why anti? Because we are dividing. In differentiation, we were multiplying. Anyway, that's just my fun name for you to remember, not any formal name. Okay, clear? So there you go, and that's our answer direct. Everyone got this, what I said? E to the power 3x divided by d dx of 3x is 3 plus. But better we do this by substitution, right? We are going to learn later that better you do these kind of things, because when it gets complicated, we'll say let 3x equal to t, and we are going to do all that by substitution when we get there. So don't worry, we are coming to that, right? But this is just the quick trick. And in fact, you know, when you get into more complicated questions, when only this is a small part of it, so Actually, you should show this by substitution and all if this is the individual sum. But when e to the power 3x is a part of it, then you can use this quick trick. Okay, that's it. So like if you have got this question, how will you do? Remember we had talked about those properties of integrals. So see, if you have two functions, you can break them, constant is there, you can pull them out. So all these kind of things you should be using, right, to your advantage. So we talked about these properties, so go ahead and try it out. So you can clearly see we can break it down. We can break it down. Integration of 4 e to the power 3x dx plus integration of 1 dx. So here what will you get? The constant comes out 4. E to the power 3x we just discussed. E to the power 3x divided by, this will become divided by 3 plus c plus integration of dx will be x plus another c. So this I can call C1, this I can call C2. Will you leave the answer like this? No, because C1 and C2 we can combine into one C. Otherwise C will start crying again, right? So the constants can always be combined. So don't sit and write two constants. So basically this is going to be, so you guys got the idea? It's actually going to be, directly you can write this. You don't have to do that step. You just do everything and then finally write the constant. This is just to understand the concept that constants can get added, subtracted, whatever. It's just a constant. So there you can see that's our final answer. I hope I wrote the 4 over there. Yeah, that's it. Easy, simple. Next one, let's try. Integration root x minus 1 by root x whole square dx. So now you can see the question is a little more complicated. There's root x minus 1 by root x and integration of that, but it's something to the whole square. There's no direct formula here that I can apply, right? So what you can do is here then expand it algebraically, simplify it, right? More than integration sum, it is first an algebra sum. So you just do a minus b whole square formula, right? So a square plus b square minus 2ab. So it will basically become root x whole square will be x plus 1 by x minus 2 root x times 1 by root x dx. This part will get cancelled. Got it? So integration x plus 1 by x, basically this. So you can break it down. Now can you guys finish it for me? Now can you finish it for me? Try it. That's the hint for you. So see, once you have got till here, now integration of x is x square by 2, x to the power n plus 1 by n plus 1. Integration 1 by x, very important, is log x. How you can remember that? ddx of log x is 1 by x. So when you integrate 1 by x, it is log. Clear? When you integrate 1 by x, because see this 1 by x guy, this term is important. This basically is integration 1 by x. If you say, sir, I'll apply this concept x to the power minus 1 dx. So that will give me x to the power. If I apply x to the power n formula, what is the problem? X to the power minus 1 plus 1 divided by minus 1 plus 1. Okay, now I'm going to jail because that is division by 0. X to the power 0 divided by 0. Gone. You have to go to jail. Division by 0 not allowed. So here basically we'll apply the formula. We know ddx of log x is 1 by x. So integration of 1 by x is log x, right? So the correct formula to use over there is, so the correct thing to use, integration 1 by x dx. Don't use that formula there. That's why it said n not equal to minus 1. This will be equal to log x. Log means to the base e. When we say this log, it is to the base e. So anytime you just read the simple log, it's to the base e. And then this is minus 2x and see all the one constant. You don't write C1, C2, C3 and all. That's it. Got it? Everybody has got this? Tell me a yes or no, guys. Tell me a yes or no. Got this? Simple, awesome, easy, nothing difficult. Now if I give you this, integration x cube plus 5x square minus 4 by x square, you'll like, oh my god, now what do I do? It's not that difficult because you have the numerators looking complicated, but there's only one simple term in the denominator. So sit and divide, right? Just sit and divide. So you'll get integration x cube by x square, which is x, plus 5x square by x square, which is 5, minus 4 by x square dx. That's it. So basically you've got integration x dx, right? This entire thing, plus 5 dx minus 4 and x square is 1 by x square is x to the power minus 2. Done. Now you can apply your formulas. This will be x square by 2. This will be 5x, this will be minus 4, x to the power minus 1 by minus 1 plus constant. Done? Done? Easy? These are all simple. There you see, and then finally simplify, you can write that as 4 by x and done. So that's the idea. Break it down. If you can break down the terms, break it down and complete it. Next, try this one. Numerator is complicated, but now denominator also has two terms. So now what will you do? X cubed by x minus 1, nothing is cancelling. What do you do now? So in this kind of integration questions, rather than jumping into some integration formula, see if you can first simplify it algebraically, right? Because that will become very easy. So can we do it? Yes, I think we can easily simplify it. It's a simple question because you can see x minus, if you take x common here or x square common, sorry, this is more like factorization. Let's see if we can break it into its part. So this will become x square x minus 1 plus 1 times x minus 1 divided by x minus 1 dx. Everybody got this? Now combine these two terms. So what will we get over here? Integration x square plus 1 times x minus 1 divided by x minus 1. Just grouping, right? Taking out the common factor there, grouping. Here you can see these two get cancelled. Now see, the question becomes so easy. You can solve this definitely. Integration x square plus 1 dx. And you can finish it off, right? Integration x square dx plus 1 dx, that's it. X cubed by 3 plus x and plus the constant small c or capital C, you can write whatever you want. Done? Easy? Exactly. So see, so basically the moral is that if you can simplify the algebraically, then why to go for complicated integration? So you are getting a simple, right? Just like you should simplify your life, simplify the question. This one also you guys can do it for me, easy. So you got 3 parts to it, right? So and see if you can apply 3 formulas. So this will be what? 2 integration x square minus 3 integration, and of course dx, right? So dx minus 3 integration sine x dx plus 5, and all these square root, guys, write it to the correct power so it becomes easy for you to apply the formula. X to the power half dx. Now you can finish it for me. Each one has its formula. X square dx, sine x dx, there's a formula. X to the power half dx, finished. Here you apply the x to the power in formulas. Here this will give you minus cos x, right? There you can see. So this thing, integration sine x is minus cos x. Here you add 1 to the power and that's your final answer. Now of course write it in a nice simplified way so that it looks nice, plus your constant. Done. Any doubts here? These you have to take care of, right? That integration, like ddx of sine x is cos x, but integration of sine x, the sign gets reversed, minus cos. So otherwise, you know, the answer will go wrong by a sign. So make sure you're putting in the correct sign. Now this minus minus becomes a plus. Got it? Can you guys do this one for me? Can you do this one for me? So see again, see if you can simplify this. So if we just go ahead and multiply it out, sec square x dx. So this is my hint to you. And here you've got sec x tan x dx. Do we have formulas for these? Check your list. Check your list. Do we have formulas for these? The answer is yes. Integration of sec square x is tan x. Why? Because ddx of tan x is sec square x. ddx of sec x is sec x tan x. So integration is the reverse process, plus c. Done. All of you got it? So here basically we are using direct formulas, antiderivatives. The antiderivative formula list that I give you, that big list of 3 pages, write it down, learn it. Basically if you know your differentiation formulas, integration becomes very easy. So one set you know, the other. These all are just the reverse. Just the reverse of derivative formula. Try this one. How will you do this? Integration of sec square x by cosec square x. So see, there is no direct formula for this, right? There is no direct formula. So sec square x, cosec square x. You know, when things get confusing, I usually turn it into sine and cos, right? Into sine and cos. I don't like all this sec, cosec, right? Reciprocal, guys, I don't like. So this we'll change it into sec square x means 1 by cos square x here. And this cosec square x means sine square x. So see, this basically becomes, the question becomes integration of tan square x. Yes or no? But let's check the list. We'll go to the list. Is there a formula for integration of tan square x? Is there a formula for integration of tan square x? No. If you look at the integral list, you have integration of sec square x is tan x, but there's no formula for integration of tan square x. So now what do we do, guys? We are stuck. What do you think we should do here? See, I showed you the list. So this guy is there, but we wanted tan square x formula. That unfortunately is not there. Can we do something smart? So what do we do? So remember, you have the trigonometric identities. Remember, 1 plus tan square x is nothing but sec square x. Sec square x formula exists. So tan square x, why don't you write it as sec square x minus 1, right? Why don't you do this? Sec square x minus 1. Finished. Then you break it down. Integration of sec square x dx, that you're confident, you know the formula, tan x. And integration of 1 is so easy. X, or it will become minus 1, so minus x plus your constant. So simple. So this is why first try to simplify stuff before you go to complicated techniques. For complicated questions, there are techniques. But first try the easy way. Try the easy way in life first. Okay. That's it. Next, another interesting question. So these are more of, trigonometry manipulation than the real integration. So see, the denominator is simple. So maybe you can first try dividing, breaking it down, right? So break Try to break it down into parts. Integration of 2 by cos square x minus 3 sin x by cos square x, and of course dx. This will give you what? 2 integration sec square x, and we have a formula for that. Good news, right? And here minus 3 integration of, what will this give you? Sin x by cos x is tan x, sec x tan x also a check. We have a formula for that. Check, check. So there you see, integration of sec square x is tan x and integration of sec x tan x is sec x. There you go. So just a bunch of little trigonometry tricks and the question becomes easy. Another very interesting question, if ddx of fx, so all these questions we have taken from the NCERT textbook, right? So now your NCERT textbook, when you pick it up, many of the questions are done. The remaining, there are a few more, you can do those also, right? But you have got a good variety here. So this one also, see, ddx of fx is 4x cubed minus 3 by x to the power 4, and such that they have given you the function at 2, not the f dash x, the function at 2 is equal to 0. Then they are asking you to find the function. So how will you do this? I want all of you to try. So how to start this question? First, write down what we have been given here. ddx of fx, that means basically I have been given f dash x, right? I have been given f dash x is given to me as 4x cubed minus 3 by x to the power 4, and they want us to find, what is our goal? Find fx. So what did I teach you when starting the class? If you are given f dash x and you want to find fx, how will you do? By integration. If you're given fx, you want to find f dash x, what do you do? Differentiation. This time you're given f dash x, you want to find the fx. So what will you say? You'll say integrating on both sides with respect to x, with respect to dx. So integration of f, got the idea? This is the concept, right? We are integrating on both sides. Or directly you can write that to get this, this is basically your fx, right? But if I integrate f dash x, I am going to get my function. That's the way to get it, by doing this integration. So integration 4 comes out x cubed dx, minus 3 comes out integration x to the power minus 4 dx. Done. So you can do this integration for me. But look at the answer. There's no plus c. There's no plus c. They have given you actual value. So how do I get to this? So whatever you solve this, right? Whatever you solve from here. So when you solve this, I think you should get something like x cubed. This will be x to the power 4 by 4. So 4 will cancel. X to the power 4 here. And same way here. This is minus 4. So you'll get minus 3 by minus 3. That will cancel. So plus 1 by x cube, I think you'll get, plus you'll get a constant capital. Now how do we find the value of that constant? So now look at the question. They have given us some additional information that the function at 2, if at 2 means what? At x equal to 2, the function is equal to 0. So now you put over here the function, put x equal to 2. This is my function fx. This is what I've got. This is my function fx. So f of 2 will be what? F of 2 will be 2 to the power 4 plus 1 by 2 cube plus the constant, and that they have told me is 0. You can solve this, get the value of the constant and plug it in. Done? Got the concept? This is the concept, that if they have given you some additional information, you can actually work out the constant and you can get the final answer. So see, we got this plus c. Now substituting x equal to 2, f of 2, you got 0. So your constant turns out to be minus 129 by 8. So this will be the correct option. X to the power 4 plus 1 by x cube minus 129 by 8. So correct answer will be this, option number A. See, you can actually calculate out the constant and substitute it. Done? Okay, so till now what we have done? We have done integrals using the antiderivative formulas, right? Using the standard functions, we have basically used the antiderivative formulas, the inverse of the derivative formulas that we do, antiderivative formulas. So we have done simple questions like integration 3x square will be x cube, or integration cos x will be sin x, and so on, okay? But sometimes if you get, like we saw, if you get integration of tan x or tan square x we could still convert it, but integration of tan x, sin x by cos x, what will you do there, right? Or if you get 2x by 1 plus x square, then you don't know a function whose derivative is tan x or whose derivative is this. We don't know from the derivative list. So then how do we do these integrations? These type of integrations, how do we do? That is why there are some more methods. So till now we have covered, there are some more methods of finding integration. So till now we have covered the formula method, which is the antiderivative formulas, right? We have used the antiderivative formula, okay? Now we'll be going into, next we'll be looking at the very interesting substitution method. Like these kind of questions, maybe they can be worked out with the substitution method. And it doesn't stop there. In integration, you have trigonometric identities, particular functions, past. These are all the technique, and these are arranged in the order of, difficulty or ease. So you should try this one first. Doesn't work, try this. Doesn't work, try this. Just like in life, one thing doesn't work, try the next thing. The next thing, it doesn't work. It's like the famous book, Who Moved My Cheese? Have you guys read that book? I think by Spencer Johnson. One thing doesn't work, the rats, they try the next thing. They don't sit there, oh, are you? It's not working, what should I do? What should I do? Right? Try the next thing. Try the next thing. Same way here. Okay. So now we're going to look at the substitution method. So for example, this question, there's no direct formula. Though I had taught you a formula, right? So, but there's no direct connection of integration sine 5x, right? Sine x, integration sine x, you guys know is minus cos, okay? That you know. But sine 5x, how will you do? Remember I told you we'll revisit it. I think there our question was sine 2x. This time I've changed the value, sine 5x. So by formula technique, we had said, remember, the answer we were expecting was what? You guys remember, it will be minus cos, right? What was it? You take as if the 5x was x. So it should be minus cos 5x, then differentiate 5x, that anti-chain rule, right? So differentiation of the 5x is giving you 5, so divided by 5 plus constant. This is what we expect to get. This is our expectation by the formula. But this time we are not going to do that. We are going to prove this with substitution. Substitution means what? Just like in chain rule, we are going to say let 5x equal to some other variable, let's say t. So we'll start off with saying let 5x equal to t. Everybody write that, okay? So therefore that will become sine t. But the problem is, so you'll say, okay sir, let's do that. So basically what do we need to do? We'll be integrating sine t dx. But that's a problem because there is a variable problem here. You've got sine t and dx. You can't say, oh sir, that's minus 5t. That's minus cos 5t. No, this is, you have to have the same variable. You can't have t here and x here. So we have to change that dx guy also. But you'll say, how do I do it? I know 5x is equal to t, but what is dx? So remember, to get dx, you can differentiate this guy with respect to x. Can we do that? So since you want dx, you do ddx of 5x equal to dt dx. Got it? What is ddx of 5x? 5 times ddx of x, which is 1. This is dt dx. Now what are we interested in? We want dx. So what is dx? You want the dx, right? So you can take the dx over here is dt by 5. Yes, you can take it like a fraction. Dx over here is dt by 5. So now see what I'm going to do. Integration sine t, because we substituted 5x as t, so integration sine t, the dx you need to replace with dt by 5. And this is absolutely fine because now you have changed the variable to t and now 5 is a constant. Constants don't interfere. They're lovely guys. They come out of the integration. So come out please. So he comes out 1 by 5 integration sine t dt. Now you'll say, now sir, I know the formula, antiderivative formula, integration because ddt of cos t is minus sine t. So integration of sine t will be minus cos t. So now you're confident, you'll say, okay, integration of sine t will be minus cos t plus constant c. And remember not to leave t, the answer in t because the question was given in x. So we'll go back and substitute t as 5x. So the final answer is minus cos of 5x by 5 plus c. And please check, have we got the same as the formula that we had? That time we had just memorized it as a technique or a chain rule formula. Now I've really showed it to you, okay? So see, the taking x, the 5x as x divided by doing the differentiation of 5x, so 5 plus c. Got it? Give me a thumbs up. Did you get this? I've explained you the full technique, okay? I've explained you why we are doing it. Because you have two different variables here. You can't do that integration, right? It's like you can't add up dollar and rupee, right? Either you have to convert dollar to rupee or rupee to dollar. So I have to convert my dx to t, right? Since I changed the x into t, so I now need to change the x into dx into dt. I showed you how to differentiate and done. And by the way, so when you have written this let 5x equal to t, you can either differentiate with respect to x or with respect to t. It doesn't matter, right? Because you want a connection between dx and dt. So another alternative of this is, right? And typically you'll see they'll do with respect to t. I just showed you because in the flow I was showing you x, right? So here you can also do this. If you differentiate with respect to t, here I differentiated with respect to x. If you do with respect to t, what will you get? 5 dx dt. And on the right hand side, ddt of t will be 1. So what will your dx be? See, dt by 5. So I want to show you the same thing you'll get. Okay. Typically you'll see they differentiate with respect to t. The parameter that you introduce, you'll see that they differentiate. There's another shortcut also, later I'll show you that as well. But we typically you'll see they'll write in the books differentiating with respect to the t, the parameter that you introduced. Okay. You can differentiate with respect to x also, you'll get the same thing, same matching. Okay, so there you can see, so let 5x equal to t, differentiating, see, with respect to, very important, there I should have written with respect to x, then with respect to t, see there you got it, substitute over there, and then in the end don't leave the answer in t, you have to come back to x, done. And so we have proved that shortcut formula that we learned, we have proved it clearly by substitution. Let's try another substitution question. So see, integration square root of ax plus b dx. So there's no direct formula for this, so what will you do once again? Let ax plus b equal to t, because this ax plus b to the power half is not helpful. But now you can clearly see that if I put that, it becomes t to the power half. You can see that, right? So the question becomes much easier, because the question will now resolve into t to the power half. But again, that variable problem. Are you getting why we changing the variable? Because you'll say, why do we care about the dx dt relation? Because of that guy, right? T to the power half, that's a great job, but we can't do integration with dx. We have to change the variable. So how do you change it? Differentiate with respect to t. So what will you get over here? A dx dt. This a and b are constants, x and t are variables. This is also one very important thing. A and b are constants, x and t are variables. So this will give you plus 0 and ddt of t is 1. So basically what are we doing? Differentiation with respect to t. Got it? So here how can we write dx in terms of t? So dx will be dt by a. Makes sense? Because a dx is dt, so dx will be dt by a. So substitute it here. Integration t to the power half and dx will be dt by a. So the a comes out 1 by a. Integration t to the power half will be what? Just add 1 to the powers. Half plus 1, so t to the power 3 by 2 by 3 by 2. And so, and plus the constant 2 by 3a. Now t was what? Ax plus b. So don't forget to substitute that guy. There you go, that's the answer, please check. Got it, how to use the substitution technique? That's it. So see, nicely simplified. So 2 by 3 this thing and to the power 3 by 2 like we showed over here. That's it. And once again you can see, typically you'll see they do differentiation with respect to t, and then it's treated like a fraction. This is another beautiful thing, right? It's treated like a fraction, take the dt there, dx here. So you can easily write dx in terms of dt, just like a simple fraction, okay? Because after all, differentiation is delta y by delta x, dy by dx, right? Here the variable names are different, dt, dx by dt. So we can cross multiply like a fraction. Now look here, integration of this. Now what will you do? What will you do? Now question is, will you take 2x as t, 1 plus x square as t, or x square is t? Which one will you take? Because see, there is no direct formula for this. There is no direct formula, antiderivative formula for this. So which one will you take? So hint is, try to take that guy as t, which when you differentiate, remember we are differentiating with respect to t, you will get the other guy. So what do I mean by that? So if you take, like if you look here carefully, if you do differentiation of 2x, you get 2. That's just a constant. But if you do differentiation of x square, you get 2x. So I think we should take x square as t, or even better if you add the 1 to it, because 1 anyway gets out in the differentiation. So better will be, this will come by practice. So better is you take, let 1 plus x square, this entire thing, why don't you take it as t? Substitution, right? We are changing the variable. Now we are going to differentiate with respect to t. Differentiate with respect to t. Okay, come on, do it guys, do it. So when differentiating with respect to t, this will give you 0 and this will give you 2x dx dt. 2x dx dt, right? And this side ddt of t is 1. So therefore, what is this thing? Now see, not only we'll write dx, because we have been given integration. One beautiful thing happens here. This was the original question, which we changed into integration. The denominator became t. And now the whole 2x dx, right? Not only dx and dt connection, these guys are connected because the 2x dx is becoming t, right? Because we want everything now in terms of t. You can't have that mixed variables, right? 2x dx here is equal to dt. So try to take in such a way that the remaining part can combine, on differentiation gets combined with dx. So 2x dx is equal to dt. And you know integration of 1 by t, don't use that x to the power n formula, which one? Because then you'll have that zero problem. That's right, it's going to be log t plus constant. And now what is log t? T you took as log of 1 plus x square. See, 1 plus x square is always going to be positive. X square is positive, 1 is positive, no problem. Okay. Everybody got this? Check it. Everybody got it? So see, on differentiation, this is what you got. Dx is dt by 2x. So you can substitute there and the 2x will get cancelled. Or you can notice that 2x dx is equal to dt. Whichever way you do, you'll get the same answer, because here you can see the 2x got cancelled here. The 2x terms got cancelled. So integration of 1 by t dt, same variable, great, perfect. Now you substitute it back and done. Try this one, try this one. So here that's the deal, right? You have to decide whether to take log x or x. Which one will you take as t? That's your choice. Which one will you take as t? Tell me. See, when you differentiate log x, you are left with 1 by x. Think like that, because you have to do that differentiation, right? So I think we should take log x as t, because differentiation of 1 by x will not give you log x, right? So let log x equal to t. Let log x equal to t. Clear? And now differentiating. So till now what we were doing, differentiating with respect to t. But I can teach you another advanced shortcut technique. You can just think differentiating both sides. Okay. So look here what I'm going to do. Look carefully. Let me show you a nice trick. Differentiating both sides. So if this is allowed in your school, you should do it. Differentiating both sides. It's like finding a delta. Differentiation on both sides. So this side I'm going to differentiate with respect to x, this guy with respect to t, with respect to its variable. So differentiation of log x with, right, will give me what? This is going to give me 1 by x, differentiation of log x is 1 by x dx. And this guy is doing a differentiation of t, that means dt. So basically you can think we are applying the differentiation operator on both sides. So rather than doing that boring dx by dt, you can do this shortcut also, okay? So whatever, if you like this way or if you like this original way, whichever you are comfortable with. Dx by dt, see, you'll get the same thing. Here if you are done with respect to t, please see, you'll get the same thing. You would have got 1 by x dx by dt equal to 1, correct? Now you would have taken the t on the other side. 1 by x dx equal to dt. Same thing have I got here. I just said differentiating both sides. This one I kept dx as the variable, this side dt. Finished. So same thing. So you just, save some time just by doing that and not writing the fraction. Okay. So there you go. Now you can clearly see this 1 by x dx. This part is clearly the dt part. So our question basically becomes resolves to, instead of log x, I'm going to put t and t square, log x square, and dx by x, see, it's very visible, is dt. So the whole question becomes so easy. That's it. Integration of t square, isn't it beautiful? So now you're going to get t to the power 2 plus 1, so 3 divided by 2 plus 1 plus your constant, and t is nothing but we are going to substitute back as log x. So log x whole cube by 3 plus the constant. Finished. Done. Got it? Everyone got this answer? Don't forget to do power plus 1. T square, so t cube by 3 plus c, and that's your final answer. Okay, so see here I've shown you that shortcut technique. I'm just doing dt and this side 1 by x dx, and there you go. Try this next question. Try this one. What do you do here? First time you look at it, you don't notice anything, right? But again I said algebraic simplification. You can clearly see x is common. So we're going to bring out the x here, or you can break it down like this, 1 by. So that's my hint to you. Now you try. Now you try. Again, substitution means, will you put 1 by x as t or log x or which one? Usually constant, absorb it, we told you. So differentiation of log x is 1 by x. So I think we should take that whole log x plus 1 as t, same thing. So this is my hint. Let t equal to 1 plus log x. Now you try yourself. Remember that quick technique, dt, differentiating both sides. 0 plus log x is 1 by x dx. Clearly now you can see dx by x, that part is the t. So our whole question becomes 1 by t. Our whole question resolves into 1 by, this is the t part, and dx by x is the dt part. So 1 by t dt, you guys can finish it now. Integration 1 by t is log t plus c and all of that substituted. Done. So easy. So there you can see. And see here it's important to put the modulus to make sure, because the input to the log function should be positive. You cannot give log can return negative, but you can't give input it wants. It likes positive input. It can return negative, but it wants a positive input. So that's why we put absolute value here, right? because log, if you get negative value, then again you will go to maths jail. Okay, so this will be the final answer. Clear? Another very interesting question, try it out. Try it out. So clearly you can see there's no direct formulas here, right? Nothing we can do. So what kind of substitution, smart substitution can we do here? So the main decision you need to take here, that do you want to make this one t or this one t? What is the rule over there? See, because when you differentiate, if suppose you make sine as your t, sine this thing as t, when you differentiate, you get the cos, or if you differentiate cos, you get sine. So here you could actually work with both, because and then plus you'll be left with dx, right? So let's say you take sine a, this one. Let sine ax plus b is equal to t. Okay. Once again, remember, differentiate on both sides. So here if I do the differentiation, I'll get cos ax plus b, and don't forget your chain rule, don't forget the basics. I have to differentiate this also, ax plus b. So there we'll be left with only a and dx, and this side will be left with dt. Clear? So this part is okay, cos ax plus b dx. But what about the a part? So you can say that is equal to dt by a. So this we can say cos ax plus b dx is dt by a. That's it. So now my question simply resolves to this whole sine ax plus b is t, and this part can you see is dt by a. How simplified the question becomes in substitution. It's like magic. Substitution is like magic. This whole complicated question became just that, where a is a constant, pull out the constant. Wow, this is fun. Integration t dt, which is nothing but, and of course this is nothing but t square by 2, because t means t to the power 1, so t square by 2. So we'll get t square divided by 2a plus your constant, and t, remember, is this guy. So that's your answer, sine square ax plus b. So 1 by 2a sine square ax plus b. Got it? Sine ax plus b whole square, which means sine square ax plus b plus the constant. That's it. But if you guys, you don't like this shortcut method, right, of differentiating, if this is a little confusing, then you can do that standard, differentiate with respect to t, right? You will get a dx by dt, then you take the dx on one side, dt on one side, and substitute it. See, these terms will cancel, okay? Because basically what you are doing, you are converting, see, what is the goal? You should understand what you are doing. You are converting, you are writing dx in terms of dt. Because you can't do integration t dx, that has no meaning. Either you do integration t dt or integration x dx, but in substitution you change the variable, so you have to change the dx also into dt, and this is fine. Some other function, but that function must cancel, right? So finally we are left with t. See, again all the x's and everything are cancelled. Next one, integration x root of x plus 2 dx. What will you do here, guys? This is an interesting question. So these are all those questions where you have to think what to do here. What should I do? How will substitution help you here? So here again, see, if this was x square root of x, that plus 2 wasn't there, it was very easy. You would have combined the powers, x to the power 1 and x to the power half, x to the power 3 by 2. But this guy is the irritation. So maybe you can take that. You can say, hey, let's take the thing inside the square root as t. So that will become a t to the power half. Now you do differentiation. Okay, I'll do it the basic style. Or here we can actually, if you do differentiation with the shortcut, see, differentiating here, dx plus 2 is a constant is 0 equal to dt. So dx and dt are equal, finished. So my question becomes integration of, this part is square root of t, this part is square root of t, but what about this part? X is nothing but t minus 2 dt. You'll say, what's the advantage of that? Let's see. Don't give up, don't give up. Integration, this is exactly what we wanted, see? Because this will now give you integration t to the power 3 by 2, combine the powers, t to the power half. Now you can finish that for me? Yes or no? Can you finish this for me? Tell me yes or no? Yes. This is easy. We can do that. And then don't forget to put back t is equal to x plus 2. You guys can do that for me? So see, you'll get t to the power 5 by 2, t to the power 3 by 2, and put your t as x plus 2. So write the answer in a nice beautiful way plus your con. Very, very, very beautiful question. These all questions are taken from your NCERT book, so when you pick it up, it will seem really easy for you. Next one. Of course, I have not done all the questions of NCERT. You still have to do some, but it will give you the confidence once you have done these, right? So here once again you can see there is the quadratic which is under a square root, so great candidate to put as t. When you differentiate, it will give you a linear function, right? So you can take, the hint here is, let x square plus x plus 1 equal to t. Okay, you want to do it the old style with the dt's, right? So you can say this, when you differentiate with respect to t, this will give you 2x dx dt plus dx dt equal to 1. Yeah, correct. You're getting this. Or this one, maybe we should differentiate with respect to x, right? You can do either ways, right? So if I differentiate this with respect to x, this will simply give me 2x plus 1 equal to dt by dx, right? So it becomes nice and clean if I differentiate with respect to x. See, that's why that shortcut method is good. 2x plus 1 dx equal to dt. And there we got that. So integration of, and what are we left with over here? So 4x plus 2. 4x plus 2. If I take a look, that is nothing but 2 times 2x plus 1, and can you see here? It's becoming really simple. This part is nothing but your dt, this with your dx, and this part is square root of t and dx. Now you see, you can combine these two guys. This is nothing but your dt. So integration 2 root t dt. Wow! Isn't this beautiful? And now I'm sure you can finish it off. Isn't it beautiful, right? So when you did this, see, the dx went up there, just like that. You can cross multiply. 2x plus 1 dx is nothing but dt, and you're done. There you see. Or if you work this way also, the 2x plus 1 will cancel, whichever you're comfortable with, right? So these ones are a little quicker, because you can see this part, the leftover part is the dt part, and there you got only a simple variable. So finally, see, you're getting t, integration t to the power half, or root of dt, root of t dt, and that you can easily solve. And don't forget to substitute in terms of x. Got it? Got it? Nice question, right? Awesome. Next one. Again, see, integration of 1 by x minus root x dx. So first time you see this, you can't see anything common. I mean, you can't see anything that you can, directly use some formula for this. Looks complicated, but maybe you can try to take out some common factor here. Integration 1 by, if you take root x common, x is nothing but root x times root x minus 1. Now again, you have to look for, if I differentiate this guy, will I get this? Which one to take as t? If I want to try substitution, which one should I take as t? So either way you can take, but mostly root x minus 1, you'll try to absorb the constant in the t. So you try this out. Let root x minus 1 equal to t. Okay, equal to t. Now differentiating with respect to t, what will you get? So here you will get, this is nothing but x to the power half. So this will give you x to the power minus half, right? Because minus 1 divided by minus half. Okay, and here we are going to get dx dt, and this side we are going to get a 1. Got it? Now see carefully, see, write this out carefully. So basically what are we getting? X to the power minus half means nothing but 1 by root x dx. Constants, never worry about them. You can easily handle the constant. So this will go on this side, like cross multiply, minus 2 dt. Now look back at the question. Look back at the question. This thing is basically becoming integration, this 1 by root x dx. 1 by root x dx, can you see, is minus 2 dt. So you're left with minus 2 dt divided by t. Wow, so easy. Exactly. This complicated question just became this. So just take the minus 2 outside, and integration dt will give you log of t plus a constant. So minus 2 log of, what is this? Root x minus 1, right? And make sure you put the modulus so that you have only positive values going in here. Log doesn't like any negative values. That's your answer. Let's see, I hope we got that right. Oh, there's a minus. There's a mistake of a minus over there. 1 by 2 root x dx by dt. Oh yeah, so on differentiation, this one will give me, when I differentiated this was x to the power half, right? So I should have taken, what did I do here? N x to the power n minus 1. So n is x to the power half. So yeah, this should have been given. I think I got this wrong here. So how come, yeah, it should have been half outside. 2 log, but how come this fellow's matching? So let's do this step again. So there's a mistake over here. So when we are doing differentiation, this is x to the power half. So half x to the power minus half. Okay, correct. So this will go on that side. So basically I'll get 1 by root x dx is 2 dt. Yeah, this is x to the power half, so not minus half, it should have been half there. And so this thing will go here. So instead of 1 by this will be plus 2. Yeah, that was the mistake there. That's it. So see, we are getting the same answer. Clear? we'll get the same answer here. And 2 log of root x minus 1 within the modulus. Got it? Then this is another interesting question. Integration x cube minus 1 to the power 1 by 3 x to the power 5 dx. What will you do? Now see, you can clearly see that you have got a cube root over here, so probably you have to, that gives you a hint. Let's try taking this equal to t. So let x cube minus 1 equal to t. Okay, so the question basically becomes t to the power 1/3. Okay, t to the power 1/3. But what do we do about this x to the power 5? What do we do about that? That's the problem, right? So maybe if I take the question and we break this down into x cube minus 1 to the power 1/3, and this guy we break down into x cube and x square dx. You'll see why we are doing this, because when you differentiate this guy, when you differentiate on both sides, so this will be giving you 3x squared dx, that shortcut technique I'm using, is dt. See, x squared term you have, x squared dx, so you can see x squared dx is nothing but dt by 3, which you can place over there. So basically we are getting integration of t to the power 1 by 3, right? X cube is nothing but t plus 1 times t plus 1, and this whole x squared dx is dt by 3, dt by 3. There you go. That's it. Now the question became so easy because the 1/3 comes out. So this will be 1/3 integration of t to the power, when you combine these powers, t to the power 4 by 3 dt plus integration of t to the power 1 by 3 dt. And now I'm sure you can finish it for me. So see, the whole question became so beautiful and easy, because once again, see, when you differentiate this, you'll get a clue of what to do in the question. You can see that definitely there's x squared plus there's an x cube, and x cube I can easily write in terms of t. So very, very nice and beautiful question, and there you can see we get the answer based on. Please see if you are able to get this answer. Got it? Very good, very good. So similarly here you can see that what to substitute. E to the power tan inverse x, then you have 1 plus x square. So look for, if I differentiate e to the power tan inverse, or if I differentiate tan inverse x, you can inspect, you will get a 1. So that's why you should remember the formulas. Differentiation of tan inverse x will give you 1 plus x square. So that gives you the clue. I'm giving you the clue. Take, let t equal to tan inverse x. Now when you do the differentiation, dt 1 by 1 plus x square dx. That's exactly what we want. So the whole question becomes so simple, e to the power t, and we are left with dt. Finished? Now I'm sure you can finish it off for me. Can you see how easy the question becomes? E to the power t plus c, and substitute it, done. That's the idea. That's how you solve these questions, by substitution. Next one, this one, how will you do? E to the power 2x minus 1, e to the power 2x plus 1. What do you do here? This is also a very nice question. So this one trick you can do, e to the power 2x, then we have a 1 here. Now if you differentiate e to the power 2x, but you're not exactly getting what we want, because differentiation of e to the power 2x will give you 2 times e to the power 2x, but you have e to the power this minus 1 there. So what do you work with here? So one smart trick you can do is divide the numerator and denominator with e to the power x. So if I divide the numerator, so dividing numerator and denominator with e to the power x. So see what you get? Integration e to the power x minus e to the power minus x divided by e to the power x plus e to the power minus x. Do you agree? Now see what is the advantage of doing that. Now you can see that if I differentiate this denominator, will I not get the numerator? So if you say let t equal to e to the power x plus e to the power minus x. Now you do the differentiation, dt with respect to t, right? So this will give you 1. This will give you e to the power x minus e to the power minus x dx dt. Bring the t this side. dt equal to e to the power x minus e to the power minus x dx. Can you see, isn't that the numerator? So beautiful question, so beautiful, right? So there you can see you will get dt on top, and you are left with simply the t below, integration dt by t, which is nothing but log t plus c, and then you can substitute t and you are done. So very nice question, where see we'll get log of e to the power x plus e to the power minus. Got it? Take a look. So this is a really, really nice question based on a simplification trick. So I had some more questions related to substitution with trigonometric functions, but that we'll do in the next class. But you guys got the idea here how to use integration by the antiderivative, right? The formula method, and we also learned integration by substitution. So next time we'll be looking at some more questions on substitution, right? And then we'll look at trigonometric identity, okay? Integration by using trigonometric identities. So clear? So we have covered these methods today, the antiderivative formula method and the substitution method. So hope all of you enjoyed this introductory class on integration where we went through the basics and we did a lot of questions from your NCERT book. So now when you pick up your NCERT book, you pick it up with a smile because a lot of questions have been done in this class. And I would still encourage you to practice other questions as well. Don't say you're done. Practice the remaining questions that we haven't covered, and please learn the formulas because they are very, very important so that you are fast in integration and you're not scratching your head about the formula. And do check out the courses on our website manochaacademy.com and our Android app Manocha Academy. All the links are given below. Please do share it with your friends. As you know, we have courses on science, maths, coding, AI, and our IIT NEET Foundation courses. In our courses, you're going to get live classes, concept videos, quizzes, questions, mock tests, and revision notes. Make sure you have subscribed to our YouTube channel. Follow us on Facebook, Insta, and X. So stay connected with Manocha Academy and just enjoy your learning.